Alright, we're going to continue on with our understanding of Newton's laws here. We've got a few questions here to check your understanding. See if you can have a go at these. What acceleration will result when a 12 Newton net force is applied to a 3 kilogram object or a 6 kilogram object? Okay, a net force of 16 newtons causes a mass to accelerate at a rate of 5 meters per second per second. Determine what its mass must have been. How much force is needed to accelerate a 66 kilogram skier 1 meter per second per second? What is the force on a 1000 kilogram elevator that is falling freely at 9.8 meters per second per second? Okay, so have a bit of a think about those. You can just pause the clip for a while, and we'll come back and we'll give some answers. Okay, so the first one, what acceleration will result when a 12 Newton net force applied to a 3 kilogram object? It's just 12 equals 3 times 4. Okay, so the acceleration must have been 4 meters per second. So it was just 12 divided by 3. Okay, the second one, a net force of 16 newtons causes a mass to accelerate at the rate of 5 meters per second. Determine the mass. Well, the mass must have been 3.2 kilograms. That's 16 divided by 5. How much force is needed to accelerate a 66 kilogram skier 1 meters per second per second? So it's 66 newtons, just 66 times 1. What is the force on a 1000 kilogram elevator that is falling freely at 9.8 meters per second? Well, force equals mass times acceleration, 9,800 newtons. Okay, good one. Okay, this is just a little bit of a slide about force. So we'll just have a look up here. So force is the push or pull that causes a change in motion of an object. Okay, just some examples there, pretty lame examples. We'll just go past this. Okay, third law. For every action, there is an equal and opposite reaction. There's different ways to write this. This is another way of saying it. According to Newton, whenever objects A and B interact with each other, they exert forces upon each other. When you sit in your chair, your body exerts a downward force on the chair, and the chair exerts an upward force on your body. Okay, there are two forces resulting from this interaction, a force on the chair and a force on your body. These two forces are called action and reaction forces. So forces always come in action and reaction pairs. You can never have just a force sitting out on its own. Okay, consider the propulsion of a fish through the water. A fish uses its fins to push water backwards. In turn, the water reacts by pushing the fish forwards, propelling the fish through the water. The size of the force on the water equals the size of the force on the fish. The direction of the force on the water backwards is opposite the direction of the force on the fish, which is forwards. That's what we mean by an equal size but opposite direction. Okay, flying gracefully through the air, birds depend on Newton's third law of motion. As the bird pushes down on the air with their wings, the air pushes their wings up and gives them lift. Okay, so he's pushing down and the air is pushing him back up. Consider the flying motion of birds. A bird flies by the use of its wings. We just mentioned that one. All this is action-reaction pairs make it possible for birds to fly. Okay, have a quick read of that. You'll see it's just what we were saying before. There we go. Nice birds. Other examples of Newton's third law. The baseball forces the bat to the left and the bat forces the ball to the right. Okay, so there's action-reaction as the bat hits the ball. Consider the motion of a car on the way to school. A car is equipped with wheels which spin backwards. As the wheels spin backwards, they grip the road and push the road backwards, or they try to push it, but what actually happens is the road pushes the car forwards. In a rocket, The reaction of a rocket is an application of the third law of motion. Various fuels are burned in the engine, producing hot gases. The hot gases push against the inside tube of the rocket and escape out the bottom of the tube. As the gases move downward, the rocket moves upward. Okay, classic example of Newton's laws. Blowing up a balloon and letting the air escape. That's an action and reaction. Okay, that's the end of our little discussion on Newton's laws. We're going to be talking more a bit about it in class, but I hope that gives you a little bit of a bit better, clearer idea of what's going on.